Okay, the title of this talk is Einstein cuckoo process. And so, let's see, I'm going by an article by G. Bernstein Brown called What is Wrong with Relativity. It was published in 1967 in Bulletin of the Institute of Physics and Physical Society, volume 18. Right. My point, we who criticise Einstein's relativity do get published in mainstream science journals, but it was easier in the past. The reason is probably because the argument has not moved on any since. We raise the same criticisms and the mainstream fails to adequately respond. How often can you keep repeating the same arguments? Journals don't want the same article repeated again and again, but that is the situation. Mainstream cannot adequately deal with criticism, so ignores it. So we're going to look at one of the articles from an earlier time where the criticism was published, and there are others. Right, that's the article. This is the information on the person who wrote it. It's G. Bernstein Brown, a physicist who's now passed away, and he's written a few things. He's written this book, not really impressed with it, I'm afraid, but this article in the Science Journal is the one I want to deal with, so maybe I can make it bigger. No, that's big as it goes. So, as it says at the top, more recent literature of a similar orientation includes Professor Herbert Dingell's Science at the Crossroads, and it gives the link there, and the work of Professor Dr. Paul Marmette, and that was with C. Couture, and it's called a relativistic deflection of light near the sun using radio signals and visible light. So this article we're dealing with by G. Bernstein Brown, what is wrong with relativity. So start at the top. Genuine physicists, that is to say physicists who make observations and experiments as well as theories, have always felt uneasy about relativity. As Bridgman said, if anything physical comes out of mathematics, it must have been put in there in another form. The problem was, he said, to find out where the physics got into the theory. So the point I think is in the case of Einstein, it's just a lot of playing around with maths, and it's not really getting to an issue of being a physical theory, but we'll come to that in a minute. Right, next thing. The uneasiness was increased when it was clear that distinguished scientists like C. G. Darwin and Paul Langevin could be completely misled. Right. Darwin wrote a fatherly letter to nature, 1957, describing the simple way in which he explained relativity to his friends. The simplicity, however, was due to the fact, with the exception of a quoted formula, there was no relativity theory in it at all. So Darwin gave a little talk explaining relativity theory, and it was actually nothing to do with relativity, really nothing apart from that little formula. So he completely misunderstood what relativity was about. Next person, Langevin, likewise gave a supposedly relativistic proof of the results of an optical experiment by Sagnac, but his countryman Andre Metz said, although elegant, it was not relativity. So once again, somebody's talking about what they think is relativity, and it turns out it's not. They're just getting misled. There was other disturbing features. The fact that Einstein never wrote a definitive account of his theory, and his first derivation of the Lorentz transformations containing velocity of light of c minus v, c plus v, and the square root of c squared minus v squared, quite contrary to his second postulate that the velocity of light was independent of the motion of the source. So he's putting into his equations something he shouldn't really be putting in if he's assuming light speed is constant. I should have twin paradox. I should have got that up. Twin paradox. Where is it? Twin paradox challenge. Open letter. And this is the site. The twin paradox. Open letter to the physics community, and we are challenging the physics community about twin paradox because they don't give a definitive solution to the twin paradox. They just give lots of different solutions, and they're not all in agreement with each other. So you don't have a definitive version of relativity. You've just got lots of people saying lots of different things. Einstein never wrote a definitive account of his theory, so there's lots of things. It's vague, ambiguous about what he's written about his theory, and people will end up thinking different things as to what the theory is. And I think I pointed out one of the problems. Well, there's actually loads of them. But if I go back to hopefully get it back. Should have had this all lined up, but I didn't. Right, so the lie. This is the one. The lie on which Einstein's relativity is built. So, is the speed of light constant or isn't it in the context of special relativity? And one of the problems with it is it defined constant or is it assumed constant? If you are defining the speed of light as constant in vacuum, in inertial frames, free of fields, etc., that is a different theory than if you were assuming it constant and then trying to check by experiment. So you've got that ambiguity there, and you've got lots of ambiguities in what Einstein's talking about. So the theory is just not definitively defined as to what it really is. So hence why we're getting things like this twin paradox, where you've got the people who believe in relativity just giving lots of different versions of what they think is the answer to twin paradox. They don't have one version of relativity, they've just got lots of different ones. Did I point out, by the way, this guy was a physicist, whose article I'm quoting. So, Einstein never wrote a definitive account of his theory, so it's left it all vague. It's like reading a prediction in the astrological column of a newspaper. It's all very vague and ambiguous. His theory is vague and ambiguous as to what it really is. It's all open up to interpretation as to what really was he talking about. It wasn't precisely defined. Right. And his first attempt to prove the formula E equals MO c squared, suggested by Poincaré, was fallacious because he assumed that he wanted to prove, as was shown by Ives in 1952. So his attempt to prove E equals mc squared, with m being in this case the rest mass, was completely false. It was a failure, and I think I pointed it out. That's in a more up-to-date book on Einstein. This professor of relativity is admitting that Einstein's maths is very bad, and his attempts to get that equation with force. It's full of mistakes, and this is what Ives is pointing out in 1952. Einstein's attempt to get that equation was false. It's a failure. He assumed what he wanted to prove, so it's just stupid. I can't keep using the word nonsense all the time, but it is nonsense again. Right, next, and then my article in my video, if I can go back to it. It just so winds me up, this does. Einstein gets away with talking nonsense. Right, here we go. Here we go, Einstein poking his tongue out of you, and I'm saying, if you read Einstein, then I say it's a valid conclusion to reach at the end of reading him that he's just talking nonsense. It's a valid conclusion. It is not surprising, therefore, that genuine physicists were not impressed. They tended to agree with Rutherford after Wien had tried to impress him with the splendours of relativity without success. So this person at Wien is trying to impress Rutherford. Rutherford is English, I think, without any success, and he exclaimed in despair, "No Anglo-Saxon can understand relativity." He's saying that to Rutherford, presumably he's an Anglo-Saxon. Rutherford replied, "No, they're not so. They've got too much sense." He's saying that Anglo-Saxons got too much sense to believe in relativity. And this is quoted from a Rutherford Memorial Lecture to the Physical Society, 1954, by Blackett. Right. But I think you can say since then, no, a lot of Anglo-Saxons have been stupid and they just believe relativity. They're told to believe it, and they do. First of all, a little history. There is no need to repeat the accounts now given in many textbooks of the unsuccessful attempts to detect the ether. So I've gone into that, and I think that's better than saying there was a small effect of the ether, but they're sort of like tending to ignore it. And I think a look at Tom Bethel has gone into more detail about that. He's explained there was a small ether effect. So go back again. Yeah. The simplest hypothesis, namely that the ether did not exist, and that we were thus left with action at distance or ballistic transmission, was held to be unacceptable. So even if you say the ether doesn't exist, there's a possibility of other theories such as action at distance or ballistic transition, and this is besides what Einstein's talking about. So you've got other ways of explaining what's going on, but as I say, the ether I think does exist, and it's a small effect. So instead, Poincaré preferred to raise this failure to a principle, the principle of relativity, saying the laws of physical phenomenon must be the same for a fixed observer as for an observer who has uniform motion of translation relative to him, so that we have not and cannot possibly have any means of discerning whether we are or are not carried along by such a motion. And that's the end of that quote. As a result, there would perhaps be a whole new mechanics where the inertia increasing with the velocity of light would become a limit that could not be exceeded. That's Poincaré in 1904. Right. And in the next year, 1905, Einstein's miracle year, Einstein restated Poincaré's principle of relativity and added the postulate that the velocity of light is independent of the velocity of its source. From the principle and the postulate he derived the Lorentz transformation equations, but in an unsatisfactory way, as we have seen. So the unsatisfactory way he did it, I think I pointed out, the method of Einstein is like is this. When you look at the method he's using, Einstein is using mathematical nonsense is the way he's doing things. Just nonsense. So you can start off with whatever, assuming whatever you like, and he just ends up making a mess of it. And that book, where is it gone? And that book, yeah. That book admits Einstein's no good at maths, but it doesn't go far enough in accepting how bad he really is. And another curious feature of this now famous paper, which he did in 1905, is the absence of any reference to Poincaré or anyone else. As Max Born says, it gives you the impression of quite a new venture, but that is, of course, as I've tried to explain, not true. And Born said that in 1956. So you're reading Einstein, he's given no citations of where what he's working from, but presumably he's working from Poincaré, but we don't really know. He's making it out like it's something new. It really is. Probably you could really interpret it as Einstein's reading Poincaré and really making a mess of it. Right, go down a bit more. Right, in 1906, Planck worked out the new mechanics predicted by Poincaré, attaining this well-known formula, and the corresponding expressions for momentum and energy. In the next year he derived and used the mass-energy relation, and 1906, 1907. In 1909, Lewis drew attention to the formula for the kinetic energy. So it's people doing other working on this, but if you're going by Einstein, you're working from what he's already messed up. And from that, it suggested the last term should be interpreted as the energy of the particle at rest, and that was Lewis 1909. Thus gradually arose the formula E equals mc squared, suggested without general proof by Poincaré in 1900. Right, so it will be seen that, contrary to popular belief, Einstein played only a minor part in arriving at the main ideas and in the derivation of a useful formula in the restricted or special theory of relativity. And Whittaker called it the relativity theory of Poincaré and Lorentz, pointing out that it had its origin in the theory of ether and electrons. And that's Whittaker writing in 1953. A recent careful investigation by Kiswani confirmed this opinion. He summarises Poincaré's contribution as follows. As far back as 1895, Poincaré, the innovator, had conjectured that it's impossible to detect absolute motion. In 1900, he introduced the principle of relative motion, which he later called by the equivalent terms the law of relativity and the principle of relativity. In his book Science and Hypothesis, published in 1902, he further asserted in his book that there is no absolute time and that we have no intuition of the simultaneity of two events, mark the words, occurring at two different places. In a lecture given in 1904, Poincaré reiterated the principle of relativity, describing the method of synchronization of clocks with light signals, urged a more satisfactory theory of the electrodynamics of moving bodies based on Lorentz's ideas, and predicted a new mechanics characterized by the law that the velocity of light cannot be surpassed. This was followed in June 1905 by a mathematical paper entitled Sur la dynamique de l'électron, in which the connection between relativity, impossibility of detecting absolute motion, and the Lorentz transformation given by Lorentz a year earlier was recognised. Right. In a point of fact, therefore, Poincaré was not the first to enunciate the principle, but he also discovered in Lorentz's work the necessary mathematical formulation of the principle. All this happened before Einstein's paper appeared, and this is what Kiwanski is saying in 1965. So Einstein's paper is 1905, and all this was done before him. Right, So now we get on to what Einstein did. Einstein's attempt to derive the Lorentz transformation equations from the principle of relativity and the postulate that the velocity of light is independent of the source would, if it had not involved a contradiction, have made Lorentz transformations independent of any particular assumption about the construction of matter as it had not been in Lorentz's derivation. So what we're saying here is the maths that Einstein was doing involved a contradiction. It was back here again. What you got is Einstein's math is nonsense. So the way he's done it, he's worked from the principle of relativity and the postulate that the velocity of light is independent of that source, and he's done a lot of maths and it doesn't make any sense. This feature of course was pleasing to the mathematically minded and poorly considered it an advance. Einstein said that the Lorentz transformations were the real basis of special relativity theory, and Einstein said that in 1935, and this makes it clear that he had converted a theory which in Lorentz's hands at any rate was a physical theory involving, for instance, contraction of matter when moving with respect to the ether, into something that is not a physical theory in the ordinary sense, but the physical interpretation of a set of algebraic transformations derived from a principle which turns out to be a rule about laws together with a postulate which is or could be just the algebraic expression of a fact. The independence of the velocity of light of that of the source, experiments already done appear to confirm it, but more direct evidence is needed, and I think in my talks here we say that it didn't. You can go back, there is a small variation in the speed of light, so it wasn't really confirmed, and that means there's an ether in one of these talks. Yeah, that one. The lie on which Einstein's relativity is based, it points out that they were not really able to measure the light speed as being constant. So if you're trying to do an experiment to measure the light speed as constant, they weren't able to do it, and then they had to change the theory and go with a theory where you define the light speed as constant. Here we go. So what we're talking about here is basically Lorentz's theory is a physical theory, that Lorentz was working on the physics, he was developing a theory based upon what he was working upon, and then Einstein comes along and he makes a lot of mess in the maths, and so it stops being a physical theory. It just becomes about Einstein's mess in his maths. His maths is just a mess, and they're saying, what? It's a different thing. Einstein's mess and making maths, go back. In the hands of Einstein, it just becomes mathematical nonsense. In the hands of Lorentz, it was about getting a physical theory about measuring things and putting it down as maths. And in the hands of Einstein, it just becomes about all his maths mistakes. So Einstein, and this makes it clear that he had converted a theory which in Lorentz's hands at any rate was a physical theory. Lorentz had a physical theory involving contraction and so forth with respect to the ether, into something that is not a physical theory in the ordinary sense. In Einstein's hands, the theory becomes about his maths mistakes, and his maths mistakes is about the physical. Some of it is about the physical interpretation of the algebraic transformations. So in 1905 paper, Einstein is rejecting ether and Lorentz is going with ether. So Einstein says, right, we've got this maths and we're not going to interpret it as ether anymore. So he's imposing all his stuff onto it. We see then that relativity is not an ordinary physical theory, it is what Singh called a cuckoo process. So that's where we get the word cuckoo process. Einstein has suddenly turned what was a physical theory from Lorentz into a cuckoo process. That is to say, nature's laws must be found first, and then they can perhaps be adapted to comply with the overall principle. The eggs are laid not on the bare ground to be hatched in the clear light of Greek logic, but in the nest of another bird, where they are warmed by the body of a foster mother, which in the case of relativity is Newton's physics of the 19th century. And that's Singh, 1956. The special theory of relativity is founded upon two postulates. This is from Einstein. A law about laws, and that's Poincaré's principle of relativity. B, an algebraic representation of what is or could be a fact, that the velocity of light constant, independent of the velocity of the source, and its application to the physical universe. And as I keep saying, that they've never found the velocity of light constant. They never found it in the context of velocity of light in inertial frames, free of the influence of fields and so forth, in a vacuum. Right, and so the extra bit that Einstein actually adds, he adds a cuckoo process. So he's got those two things, and then he goes cuckoo, bananas, goes nonsense. This basis of the theory explains a great deal that has mystified many physicists and engineers. The cuckoo process. That is what has mystified people. And that's why it's nonsense. What Einstein's doing is nonsense. It's the cuckoo process. They could not understand how Einstein could sometimes speak as though the ether was superfluous. That's Einstein 1905. And at other times say space without ether is unthinkable. And that's Einstein 1922. So one minute he's saying no ether, next minute he's saying there is an ether. So how does he do that? How does he say one thing and later say the opposite? He does that a lot. He just changes his mind, says one thing one moment, later says something else. This was due, of course, to not starting with physical terms. So Einstein did not start with physical terms. Lorentz was starting with physical terms, but Einstein was just making things up as he went along. He was sort of using the cuckoo process. And the physical terms would be matter, its motion, and its interactions, force. A physical theory would have included radiation, would have to start by stating a physical theory which included radiation would have to start by stating whether an ether, action at a distance, or ballistic transmission of force was being postulated. And Einstein doesn't do any of that. He's not starting from saying what's going on here. He's not saying we've got radiation, but he's not stating what it is. Is it ether? Is it action at a distance, or ballistic force transmission, or what? He's not saying. He's got these postulates and his cuckoo process, and he's not saying, giving you information to know what is physical about the theory. Just maths, manipulation of the maths, and the maths is a cuckoo process. It also how mass and inertial force get into special theory, which is founded on a geometrization of uniform velocities. That is what we would need to explain. For it is well known that inertial forces do not appear when the velocities are uniform. So he's not explaining things about that. Formula which purport to give the relation between measurements in one state of uniform velocity, and those made in another state of uniform motion cannot logically throw any light on what happens during the change from one state to the other. So he's not giving the physics. He's not giving the physics at all. He's not explaining what is the physics of what's supposed to be going on. He's just giving you this and this and cuckoo process about dealing with it. It's just nonsense. And so so when he's dealing with it, this is only possible by using the cuckoo process, assuming Newton's second law and the conservation of momentum, and then modifying it. So he's assuming it one moment, and then he's modifying it. What? And you say, what? So you're looking at it and say, 1 minute it makes sense, and the next minute he changes into something else, and you're saying, what? What's he done? Why? 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 What's that cuckoo process all about? What have you done? It also makes clear how Einstein could call Tolman's account of theory, that's Tolman 1934, definitive, and also praise Bergman's treatment, Bergman 1942, when the former author thought length contractions real and in principle observable, while the latter seems to have thought it only an appearance. So Einstein is claiming that is a definitive version of the theory. And then he claims that's a definitive version of the theory, and you've got two different accounts. First theory is the length contractions are real, while the other theory is it's only an appearance. So you've got complete contradictions in what Einstein is saying about his definitive version. We go back. There were other disturbing features, the fact that Einstein never wrote a definitive account of his theory. So what you've got is Einstein contradicting himself when he's given what is supposed to be a definitive version of the theory. He's just talking nonsense. It's more cuckoo process. The fact that Einstein asserted that the Lorentz transformation equations were the basis of the special theory, and these are of course purely mathematical means that insofar as the theory is considered to have any physical implications, these implications must be the result of the interpretation of mathematical expressions in physical terms. But in this process there can be no guarantee that contradictions will not arise, and in fact serious contradictions have arisen which have marred the special theory. Half a century of argumentation has not removed them, and the device of calling them only apparent contradictions, paradoxes. They like calling things paradoxes in Einstein's relativity, and then they like saying it's only apparent contradictions, has not succeeded in preventing the special theory of relativity becoming untenable as a physical theory. Right, and so then he wants to go on to the twin paradox, or the clock paradox, and I think this is probably the best place to go. Where has it gone? There, the twin paradox, our open letter to the physics community, challenging them to give us a definitive version of what is supposed to be the answer to that. Because all you're getting from Einstein is ambiguity. He's going to tell you 1 minute it's a real length contraction, and then he's going to tell you it's only an appearance. There's no definitive account of the theory. There's no connection to physics. Lorentz was given a physical theory, Einstein took the mass of that, and he's not telling you how it connects to anything in physics. So this is what he's got. He's got that, and he's got that, and it's sort of like, where's the physics? Where's the physics? It's not there. So he gives you that, a cuckoo process. It's nonsense. Just nonsense. There's nothing there. There's nothing there telling you from Einstein what's really going on. You can go to Lorentz or Poincaré and you're having some of the physics, but you go to Einstein and you're getting the cuckoo process. Hence why you're getting the total ambiguity is what's supposed to be the answer to the twin paradox. You get people who say, yeah, the twin paradox answer is so and so, then you got somebody else who says something else. And you got the cuckoo process. That's the cuckoo process put in. Einstein's cuckoo process. So this is entirely infuriating. Einstein does a lot of mathematical nonsense. He gets away with it. You so say, oh, he's a genius for doing that. Where's that book? Okay. There's that book. That book admits Einstein made maths mistakes, but from the person's point of view, Ohanian, he reckons Einstein's a genius for doing that. How stupid can you get? How stupid. Messes up the maths and he's so say a genius. And this is why you don't get many published papers like this anymore from people like, here we go, G. Bernstein Brown. You don't get many papers like that anymore, because how many times can you keep offering the same arguments against Einstein's relativity only to get them ignored? You can't keep publishing the same paper every time. What? They're just ignoring it. They're going with the cuckoo process. This is Einstein. Einstein's two postulates, and then he adds the cuckoo process, and the mainstream's just happy with that. Cuckoo process. Nonsense. We go to further on up in the scale. This is the, so say, brilliant genius of general relativity. There you go. You get Professor Ryden looks at the complicated maths of Einstein in general relativity. Takes a lot of going through to work it all out, and you work out the maths and it's just nonsense. So you start off with nonsense. You start off with nonsense. And this one, Einstein didn't know what he's talking about. They accept Einstein. A lot of them think, oh, Einstein didn't know what he's talking about. They accept that. They accept his math is bad. So they should really accept the conclusion. There he is, pointing his tongue at us. Saying Einstein is talking nonsense is a valid conclusion. It's just all valid. It's just nonsense. Everything is just nonsense. And that's where they've been for the past 100-odd years, following this nonsense. Thank you.